Okay, so remember we're talking about sound waves and some things that we saw in the video that we made is sound waves behave really different if we were to send out a sound wave. Okay, so from a voice or an instrument or whatever it might be, the thing that you have to remember is that is actually making particles vibrate and move in the air. And as that wave travels, these air particles that are here are either going to compress or they're going to spread apart. So we saw that with that slinky as a demonstration, that as the sound wave is traveling, the way that it gets it to travel is by, and we know that there's gas particles in the air. Okay, this could also happen in a liquid or in a solid state, and we'll talk about that in other lessons. But it is propagating from left to the right. So pretend like this is some noise coming from your voice or whatever it might be, and it's moving in this direction, okay, towards the right. So we labeled, and what I want you guys to do is just in your own notebook paper, you can write these things down, but we want to label these different things. And this part right here is called the compression part of the wave. Okay, this section, okay, right here, we'll label that in, is called the rarefaction. Okay, rarefaction part. And then if we look at a combination of one compression and one rarefaction, we would call that a wavelength. And remember, this is for longitudinal waves. So sound waves are a special type of wave called a longitudinal wave. Okay, a very special type of wave. All right, so we have the parts of the wave. We know that one compression and one rarefaction would equal one wavelength. Let's see what else we can find out. Okay, so I have a drawing here that is still longitudinal wave, and I'm drawing this a little, again, I'm drawing it like this so that you can get reminded that as a sound wave moves, it compresses air particles, spreads out the air particles, like kind of like in that Bill Nye video, we showed how those particles are bumping into each other, and sometimes they're really compact, and then sometimes it spreads out. So the one other thing that we can talk about, at least for now, sorry you guys, is how often does a longitudinal wave happen in a given point of time? So if we let this be the starting point, so our measuring starting point, and this be our end point, we can look and see how many waves happen in that given amount of time. Now remember, one wavelength equals one compression and one rarefaction. So I have one wave here, and then from this compression to this rarefaction, here's the second wave, and then from this compression and this rarefaction, that's a third wave. So in this particular case, we have three waves that occur in this period of time. Now, many times we allow the start and the end to represent over the course of 1 second. So if this would represent 0 seconds, and we're not going to be doing any math with this, but just so that your brain can start to process some of this, and we let this be 1 second. Okay, so from start to end, how many waves could happen in that 1 second? Well, in this particular case, we end up with having 3 waves in 1 second. So we would say something like this: 3 waves per second. Now, those of you that know a little bit about maybe some things you've learned, you play an instrument and you know things like this, this is given, this waves per second is actually given a different type of unit, and it's called a hertz. So a wave per second could also equal, and just so you can see it, I'm going to write this up here, 3 hertz. So 3 hertz equals the same as 3 waves per second. And all of this deals with the concept. I'm going to move this down just a little bit. This is what frequency is. So frequency is the number of waves per second. Oops. Per second. And it's measured in hertz. Okay, which we could abbreviate that with an HC. So hopefully this gets you going. It's letting you start to think again about sound waves and what's going on. There's going to be a form that I want you to fill out. You want to keep your notes organized because we're going to be adding on to this other characteristics about sound waves and then also characteristics about light waves. Those will be the 2 main types of waves that we're going to compare. All right, hang in there.